Hello friends, welcome to my channel. Let's have a look at a newly appeared problem. Problem 2587. Rearrange array to maximize prefix score. In this video, we're going to share a solution based on sorting. But here we are not going to present you a naive sorting, but we are going to use some modified or tailored sorting key. First, I'll read through the problem statement to digest the requirement, and then we analyze the problem, and finally we share the code. First, the problem statement. We are given a zero-indexed integer array called nums. We can rearrange the elements of nums to any order. So let prefix be the array. Actually, this prefix it will be the partial sum string. So the score of nums is the number of positive integers in the array prefix or in the partial sum sequence. So we want to return the maximum score we can achieve. So here are two examples. So in example 2, so there are only 0 and negative numbers. Therefore, the partial sums, no matter how we rearrange, so there's no positive possibilities. Therefore, the return is 0. So for this one, so rearrange is like this. So it puts negative numbers here. So 0 is sort of special also. So the output score is 6. So here the constraint is that the length for this is bounded below by 1 and bounded above by 10 to the power 5. So this 10 to the power 5 is relatively not large number. And the second constraint actually is important. It basically says that the numbers can be positive, can be negative, can also be 0, right? So, but you can here is a range. So it plays some role, but not that essential. So with that said, we are ready to do the analysis. So here we are going to use sort. So actually, there are multiple ways to do the rearrangement to get the maximum score. In other words, the rearrangement is not unique. Here I would like to use a simple example case to demonstrate to you that the rearrangement is necessary. So though not unique, right? So let's assume this is an array, right? If we do not rearrange, then the prefix sum sequence will be 0 because it's the first element. Then we have 100. Then if we do this, the number of positive numbers in the prefix sum sequence or partial sum sequence is just 1. However, if we rearrange it as 100 and 0, then the prefix sum sequence is 100 because the first one is 100. Then 0 plus 100 is another 100. Then the count of positive numbers is 2, right? So this example basically tells us this rearrangement is important. So actually, in my first submission, I actually I made some typo in the coding. So I'll explain or point out to you when we do the coding. So therefore, with the above example, we can see that we shall put positive numbers before 0 in the rearrangement. So actually, the positive numbers relative order is not essential. So this is actually a point very easy to understand. Similarly, we need to put negative numbers after 0, right? Because before 0, if there are all positive numbers, we can accumulate a very large partial sum. And then we decrement it slowly, as slow as possible. In other words, we put small negative numbers in front of the larger ones, the larger absolute value negative numbers, right? So similarly, we put negative numbers after 0, but in a decreasing order, in order to decrease the largest possible prefix sum slowly for more positive numbers. Therefore, we maximum the score. So if we do not want to be very precise for this problem, so we just need to sort the numbers decreasingly. This will do the job. Then we may compute the partial sum sequence and then count the positive numbers, right? But here I want to catch the problem core. So if we want to be precise to catch the core, we can design a sorting function which do not respect to the positive number order. So in other words, I just want to make sure the positive numbers are before 0. So their relative orders does not matter. And then we make negative numbers in decreasing order. So that's what we are going to do. In other words, we want to define a sorting key, and then we pass that sorting key to the sort function, and then we do we count the number of positive partial sums or prefix sums. So this is what we are going to do. So now with that said, let me write the code. So first I'm going to define a sorting key, right? Sorting function to catch the problem call. This is our goal, right? So here I'm going to define it as order, right? X. Though if X is positive, right? So I just return -1 to make it small so that it can be in front. And otherwise, else if X is 0, right? We just return 0, right? It's larger than the positive number's value, right? Otherwise, so X will be negative. I want to put larger negative values in front, the smaller one. In other words, the larger the absolute value, the larger it should be in the last, right? So we're going to return absolute value of this X, or negative X, right, if you like. So just negative, because X is less than 0. So this is our sorting key. Now we do the sorting. So for the sorting, we can do the sort in place. So I'm going to pass the key to be the order, right? So this order is a callable, right? So we are going to put it here. Next, so we do the counting and return. So this is simple, right? So I'm going to start from the first element. So let me first set a result. So let's check the first element after we rearrange. So let's call this one rearrange. This is maybe better. Rearrange. So I'm going to see if the first number, nums 0, is positive or not. If it's positive, I'm going to count 1, right? Then I'm going to iterate. Let me maybe write n equals length of nums just for convenience. And then for I in range, so I'm going to start from the first one and then ending at n-1. Then, so basically the prefix sum, the current prefix sum is the previous one plus the current number, right? So I'm going to do this nums I increment by nums I minus 1. So the nums I minus 1 will be the prefix sum, right? So here actually we can do a check if we like. So if this is positive, right? If nums I is positive, then we're going to increment the result by 1. So afterwards we do the return. So we return the result. So let's do the check first and then make some comment. So this is the example we made, right? So now let's look at generic case. Yeah, it passes all the cases. So here in my first two submissions, actually I made a typo here. So I wrote here greater than or equal to 0. But in this case, it will never enter this else if block. Therefore, they cannot distinguish 0 and the positive numbers. Therefore, for this kind of problem, it will going to give us a wrong result. So this is a one solution, right? Let's submit that. But if you see I'm very lazy, so we do not want to think about these details, or just don't realize that after we put the positive numbers in front of zeros, their relative order does not matter. So we can actually just do something very straightforward. Nums sort. So let me do this. Let me copy this one, and I'll change this one to be V1. So this V1 actually is what we want to emphasize. But here I just directly do the sort and sort. So basically I can put a key or can put reverse true, right? So then we just do the same counting, right? So let's test. it passes this one. Now let's look at generic case. It passes all the cases. Because I'm going to emphasize the first one, because I feel that the first version catches the core of the problem. I'm going to change this one to be the original function signature, and I'm going to use this one as a brute force without detail, obviously. So here, because we are using sorting, right? So the sorting, so the term complexity, let's see. The sorting, because it's O n log m. So where n is the length of this nonce, right? Then after we do the sorting, so we actually did a linear loop, that is O of n, right? So overall, it's O n log n, right? So this is the term complexity. So for this problem. So I guess with that said, let me give a small summary. So here we shared a solution based on passing a modified sorting key. So here I feel that the sorting key catches the core of the problem. So that's one thing. So another thing is that we are going to compute the partial sum or prefix sum. Implicitly, we are using some reset, or you can see, or it's sort of a naive dynamic programming, if you like, but it's just a for loop. So with that said, I guess that's about it for this video. Thank you.